SLRTC is one of the best institute in Mumbai University. It is our great privilege to have you. I am honored to introduce today's eminent speaker for webinar is Dr. B.B. Meshram sir. So he is a professor and former head of Department of Computer Engineering and Information Technology, VJTI, Mumbai. He has obtained his BME and PhD degree from SGGSIE and T Nanded, India. He has obtained bachelor degree LLB from Mumbai University. He is also computer hacking forensic investigator CHFI EC Council USA certified. He is a teacher and trainer and consultant in the field of computer engineering and information technology. He is actively participated in delivering guest lectures and tutorials. He has authored 10 books and over 500 plus publications at national and international and also filed 10 patents. He has guided 10 PhD students and also under him PhD students are pursuing PhD. His publication citation count is uh, 1300 H index more than 10 plus and H I index is also more than 11. He has organized several workshops and seminars in the field of computer engineering and information technology. The industry demanded MTech computer engineering in network infrastructure management system and international conference. Interface are his brainchild to interface the industry, academia, and researchers. His research interests are multimedia, database, modern information system, information and cloud security, digital forensic, software engineering. Beyond the research, he also runs the Jamin Educational Society to uplift the needy and deprived students of the society. As a responsibility towards the society and the nation, he is collaborator and a listener, well organized and change agent. He believes in establishing and improving processes for managing complex activities. He is a proponent of concise scientific, lawful thinking, and truth communication. He believes that teaching cannot be just a profession but has to be one's dhamma to serve the students. Such a great profile indeed. We have honor to have you here as a resource person for webinar. On behalf of SLRTC, I, Madhuri Gidam, welcome you, sir. Now over to you, sir. You can start the session, sir. Thank you very much, sir, for your presence.
Thank you. Is it visible?
Yes, sir. It is visible, sir.
Okay. So I welcome to you all for this session. So today we will be dealing with software architecture, or you can say that program is nothing but data structure plus algorithms. So 75 PPTs are there, and I have to finish it within 1 hour. So I will be so fast. So SRS document dictate the functional requirements and non-functional requirements. Principal design decisions include system structures, functional requirements, interaction, non-functional requirements, and system implementations. So these are specified in SRS document of the computing system. And on the basis of this SRS document, you can take the design decisions for the design and development of software architecture. So if you will think about structured system analysis and design, the analysis model can be mapped with the design model. Several diagrams are there. So these diagrams are useful. Analysis model is useful for the design model. Now, if you will think about the software architecture structures, these are divided into 3 parts: module, component and connector, and allocation. So these diagrams, module or component and connector and allocation, dictate the UML notations. So under these various structures, you can study the various concepts like decomposition, class, users, layered, client server, process, concurrency, shared data, and allocation is related to deployment, work assignment, and implementation. So these three diagrams leads to UML notations. So you can use these three diagrams to decide the software architecture, or you can also decide the UML notations. So if we will think about the module, so module view type. So for module view type, different notations are there. And with the help of these different notations, you have to deal with the decomposition, class, usage, and layered. So decomposition means modules. So with the help of modules, you can construct the package diagram. And under the classes, you can deal with various notations of the classes. And usage relationship is there. So this usage relationship will deal with among the packages or modules. And layered architecture is there. This layered architecture is user interface, web servers, application server, database servers, tier architecture, or there are many other layer architectures. This is visible to you all? Hello? Is it visible?
Yes, sir.
So there are various architectural styles, set of components, set of connectors, constant, semantic models. Architecture styles are there, like this is data center architecture is there. Then client server model is there. This is cloud infrastructure and data center architecture is there. Layered architecture is there. This is pipe and filter. So pipe and filter architecture is also there. Data flow architecture is there. So there are various types of architectures. This is filter and pipe architecture. So on the basis of this architecture, you can decide the software architecture. So these are the layered architectures. These are the layered architecture. Again, there is a layered architecture like this. This is also the layered architecture. You see, this is the layered architecture where user interface layer, application layer. So system programs like TCP/IP protocol or OSI layer model or operating system architecture. All these architectures are layer architectures. So under these layer architectures, you can decide the deployment and component diagram, and you can decide the architecture based on your interface, web server, application server, database server. Now, second type is connector type, compare component and connector. So various software components are there, and how to connect these components. So you can connect the components with the help of connectors. So there are three types of connectors, you can say, like UML subsystem, content objects, and collaborations, like collaboration diagram. Then connectors are there, like association is connector, association classes are connectors, because association class can also act as a class, and then classes and their association. Then ports are there. So on the basis of these three ways, like UML subsystem, content objects, and collaborations, and connectors and ports, you can construct the layered architecture or component and connector architectures. So under component and connector architectures, different notations are there to represent client server architecture, like Oracle client server architecture, or concurrency used to identify the requirements for controlling and monitoring the issues associated with concurrent execution. Our processes are there, and shared data is there in the distributed environment or in the cloud deployment, or deployment information is also used under the component and connector diagram. And lastly, allocation view type is there. So under allocation view type, you can deal with the allocation, whatever may be the architecture, software architecture is there, how that software architecture is allocated on different types of hardwares, or if there is a module view type are mapped to the system using the implementation style, and program databases interfaces of the CC view type are mapped to the hardware with the deployment type. So three types are there: module view type, then CC view type, and allocation view type. So all these three view type dictate the UML architecture, because here some notations are related to UML, some notations are informal notations, and they used to deal with the software architecture. So this software architecture and these three viewpoints means a one semester course. So I have to finish in 1 hour. So in allocation view time, work assignment is there, like roles, project leader, analysis designer, tester, project management team. And in deployment, you used to deal with the informal notation for the deployment diagram. If you will think about the other disciplines like mechanical disciplines or electronics, they used to deal with the block diagram for the deployment. But here we have to specify the particular notations for the deployment diagram. But when you will think about the allocation view type, just you have to use the informal notation for the deployment. And if the implementation is there, so in the implementation, how the components are allocated to the particular machines. So in the allocation view type, under allocation view type, implementation is there. And in this implementation software architecture design, you have to decide how many exe files are there, how many lib files are there, how many jar files are there, and how they are connected together, and how these are deployed onto the particular storage. And if it is deployed on a particular storage or on a particular machine, in which path it is stored, whether it is stored in C drive or D drive, or what is the particular path, in which particular path the system programs are located, in which path the software that you have developed is stored. So all this type of information is considered under the implementation. So this view, you can say allocation view or module view or CC view. All these views leads to UML, or you can say that it is a 4+1 view model. So in 4+ view model, logical view is there, process view is there, deployment view is there, physical view is there. So under logical view, you have to think about the class diagram or end user functionality. In the process view, you have to deal with the component diagram, and component diagram will be integrated with the non-functional requirements. And physical view means deployment, and development view is a module diagram or subsystem, you can say. So this 4+ view model is the original model, and on the basis of this model is developed. So in this model, 3 scientists joined together: Jacobson, Ivar Jacobson, who was dealing with the use case analysis, then Rambagh and Booth. These 3 scientists had developed their own methods of object-oriented analysis and design, but their notations were different, though the concepts were same. So what they have done, they came together and they integrated all these 3 methods by Booth, method by Rambagh, and method by Ivar Jacobson, and they come with this new model of UML. So in this UML, structural view is there, implementation view is there, behavioral view is there, environment view is there, and in each and every view, there are different types of diagram. So in the software architecture, we have studied 3 views. So these 3 views are this 4+1 view is there, and under this development view is there, and physical view is there. So development view, physical view, or you can say implementation view and environment view, they dictate the software architecture. Of course, these diagrams are analysis diagram, and this analysis diagram can be mapped with the design, and design means software architecture design. So analysis model is mapped with the design, and design indicate the software architecture. Software architectures means data structure plus algorithms. So here, map the analysis model with design model. Use the following dimension for the design of the object-oriented software. So if you will think about the analysis model, CRC model is there, class diagram is there, object relationship model is there, object behavior model is there, use cases is there. So each and every diagram is mapped with the design process. So design the software architecture. So if the question is on design the software architecture. Design the software architecture means you have to design the component diagram and you have to design the deployment diagram. And when component diagram is there, on the basis of component diagram, you can deal with the data structure design, algorithm design, and authoring system for the given project or product. Project means software project that you are implementing for the particular customer. And if it is said that software product, then software product will be a general software which can be used by many people. So analysis model can be mapped with the design model. So here, if we will think about software architecture design, software requirement specification document is with you, that is SRS. So this SRS dictate the functional requirements and non-functional requirements. So functional requirements can be captured by the use case diagram, and non-functional requirements are security, scalability, availability, quality of the software, safety of the software. So all these are the non-functional requirement. So non-functional requirement and use case diagram, that has functional requirements, will dictate the software architecture. So use case diagram is an analysis model, or on the basis of use case model, you can deal with the design model. Use case diagram can also dictate the implementation model, and use case diagram implementation can be tested by the test model. So here, if we will think about this design model, use cases, you see non-functional requirements shows the arrow toward use functional. Means non-functional requirements provide the services to the functional requirements. Then only functional requirements can work. Therefore, use case diagram depends on the non-functional requirements. And both will contribute to the design model. So under design model, component diagram is there and deployment diagram is there. So you can say that if software architecture is there, so meaning of software architecture is what? You have to design component diagram and deployment diagram. And component diagram again is divided into the database design and algorithm design. Database design will also dictate the graphical user interface or authoring system. Authoring system means the graphical user interface where images, audio, video are embedded together and various buttons and icons are there. Then you can say that it is a authoring system. So authoring system is a terminology when the multimedia icons are used in the design of graphical user interface. So implementation model dictates the code, and this code can be tested by this test model. So this is all about the software architecture. Analysis model is there, and analysis model is mapped with the design model. Now, we have studied three models: module view, CC view, all allocation view. So they have provided different types of notations, informal notations, as per their will. And they define what is that notation. But here, in the UML, these three scientists have given their own notations, and they do the work of these three models only. So three models, module view or CC view or allocation view, is stimulated by the UML model, but in UML model, allocation style is not there. Also, manpower style, this work assignment. So if we will think about this diagram, decomposition, uses, layered classes, client server, concurrency, process, share data, all these things are dictated by the UML diagram because all these things are shown by the interaction diagram. So component and connector, component means module, one particular subroutine, and they are connected together. So for this, UML has also provided the notation. But if we will think about the allocation, UML dictate the deployment diagram, but UML is shortfall of work assignment. Work assignment is not done by the UML. And implementation is also not shown. But implementation means coding. So analysis can be mapped with the design, and design can be mapped with the implementation. So implementation is not dictated by the UML, but if you will dig the UML again, some other authors, they can integrate all the diagrams and can do the implementation, because analysis model can be integrated together to give the design, and ultimately design will dictate the implementation. You can read my book, my research paper on object-oriented database design, where I have integrated all the diagrams for the data modeling and process modeling. So you can search for BB Mesram, object-oriented database, object-oriented data model and process model, Calgary, Canada. You will get the paper on the internet. So my my approach was what? Work assignment is not dictated by the UML. Work assignment. And allocation. Where is allocation? This allocation. So allocation notations are used by the UML, but that are not up to the marks. So you have to deal with some other strategy. Otherwise, if you will deal with allocation also in the deployment diagram, then the diagram will become more complex, and then it may not be in readable form. So software architecture design, software architecture, that is component diagram and deployment diagram. Component diagram means data structure design and algorithm design, or you can say data structure and algorithm will dictate the code. So program, that is code, is constructed with the help of data structure and algorithms. So software architecture. So component diagram and deployment diagram. So now what is component diagram? Component diagram shows the structure of the software elements like packages, subsystems, subroutines, and their interactions with data structures or database tables. Now, while dealing with the design of the component diagram, you have to decide which files, which components will be used in the implementation of the software. So, in the component diagram, you will deal with the source code components, object code components, executable code components, or database tables. So without implementation, you have to decide 4 tables are required for the implementation of the system, or 5 tables are required for the implementation of the system based on your class diagram or ER diagram. Now, how many exe files are there? How many jar files are there? How many lib files are there? How many exe files are there? How many CPP files are there? How many Java files are there? Because software architecture, when you will implement the software architecture, in that architecture, there may be a Python file, there may be a Java file, there may be a HTML file, there may be a XML file. So different types of coding you can integrate in making the software architecture. If it is web-based, database can also be there, Oracle database can also be there. So how many tables are there? How many files are there? What are their extensions? Because if you will say particular bbm.cpp, means there is a file bbm.cpp in the implementation. So before implementation, you are representing the diagram, that is component diagram, in terms of the object code, source code, database, executable file, library file, exe file, and so on. And after deciding the component diagram, you have to think about the deployment diagram. Deployment diagram is machine requirements, hardware requirements, application server requirement, database server requirements, or web server requirement, client requirement. And in this deployment diagram, what are the configurations of each and every machine so that you will meet the required performance of the system. So while dealing with this deployment diagram, you have to think about the non-functional requirements, whether you are in need of the router or load balancing or availability or backup servers, or do you want to deal with the printer or scanner. So in deployment diagram, you have to deal with the machines and different devices involved into that execution of that component diagram. So component diagram and deployment diagram will dictate the software architecture. Now, 2 things are there. For the construction of the component diagram and deployment diagram, you can use the informal notations and you can define. So that comes from module view, allocation view, and component and connector view. There you can use some UML notations or you can use some informal notations. But when you will come to the UML, then you have to use the particular notations of UML for the construction of component diagram and deployment diagram. I may not explain each and every notation, and we do not have time, but you can read the notations. So package notation is this. Here you can write the package name. So package notation. So if this package is divided into two packages, so this notation is used. It shows the subset content elements. This is main org, and these are two subsystems interfaces. So here interface stereotype is used. Or if it is a package regarded to the library domain, and if these are the sub elements, so catalog, patron, librarian, account, you can specify the access specifier plus public minus private. So elements of package are also accessible outside the package through the qualified names, that is plus. So package notation can also be used like this, but this is not good idea to represent the package like this, because it do not give the connectivity or interaction between different modules. How catalog is related to librarian or how account is related to patron, it is not indicated. And our package diagram should indicate the package is there. Under packages, there may be many packages. So how these packages are interacting with each other? Or in a particular package, some classes are there. So how these classes are interacting with each other? So that interaction should be shown into the package. So package notation you can use. Now, so this is online shopping package diagram. So this is package notations. Different notations are given, package notation. So you can do the online shopping with the help of web shopping, mobile shopping, phone shopping, or mail shopping. So these are the three shopping packages, and you can merge these shopping packages with the card package. So this dot is there, this dot is there, this dot is there. So all these three packages are merged toward the shopping cart. Because you have to deal with the shopping cart package, you can do the shopping with the phone, or you can do the shopping with mobile, but all these packages will merge to the shopping cart. And after shopping cart, this web shopping or mobile shopping, all these uses the payment package. So web shopping, mobile shopping, phone shopping, mail shopping, all these packages uses the payment. So usage stereotype is used in the use case diagram also. So that is similar. Use case usage relationship in the use case diagram is similar to the usage relationship in the package diagram. This payment package is common to all these packages. Therefore, these packages are using payment package. And payment package is accessed by shopping cart. Whenever you are dealing with the shopping cart, it will import the inventory. Why? Because customer want to purchase something, so customer will deal with the inventory. Therefore, shopping cart will deal with the inventory, and then only the payment can be made by the customer. So this is the representation of the software architecture, but it is at abstract level. You can also show more details of each and every package. How web shopping package is implemented, how many other packages are there inside the web shopping, how many classes are there inside the web shopping, that you have to decide. So these are the notation. You can write component, name of the component, or here you can specify the module diagram, and in bracket you can write the name of the component, or here module diagram can be constructed, and here you can write the stereotype component in the rectangle. So these are the different notations to denote the component. So component can also be denoted by this. And this is package diagram just we have seen. Now this is dependency relationship, this is generalization relationship, and this is ball and socket relationship. This is node, this is port. So you can study the different types of notations. So now the use of notations. This is one component, this is one component. So this component is in need of the interface, and that interface is provided by this component. So this component is known as service provider. So provided interface. So if this component, this notation is used here, just I have written the component and this notation I have used. And this is ball, circle, and this is socket. So circle and socket interface is there. Why? Because this component is in need of the interface of this component. Or port, this is the port. Interface is there, but this component can be accessed through this port. So small square is the port. अरुण थोड़ा मी बिझी आहे लेक्चर मध्ये, थोड़ा बिझी आहे. हाँ. So now dependencies, that arrow I have shown dot 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 dot. So this arrow is toward this component. It indicates that it is a parent component, and this is dependent component. Child component, parent component, dot 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 dot. So it indicates the dependency. Child depends on the parent. So if horizontal view is there, you can show the direction like this. So direction is towards the parent. But if you have to show vertical, then parent will be at upward side and component child will be at downward side. So model dependencies from left to right for horizontal, and place child component below the parent component when you will show the vertical representation. So this is dependency arrow, and this is database notation. This is a database notation, and tables are used. So for construction of the component diagram, you can use these notations: component notations, package notation, then this dependency notation, these dependency notations, this socket, this is the node, this is the port, and they are represented like this. Like this. Database like this. So on the basis of this various notations, you can design the component diagram. Now, all these notations are not used in the previous models like module view, common concurrency and component and connector, or allocation. They have used some of the components of the UML, and some of the components are informal, or some concept represented by these three types of views are not represented by UML. Even UML cannot capture all the requirements of web engineering. Some of the requirements of the web engineering are captured by the UML diagram, but not all requirements. And therefore, we have the new concept of web engineering. Now, I said package. Package is represented by this diagram, this notation, package. But what is this package? This package is what? So under this package, class can be there, methods can be there. Now this is one package, but under this package can be called by some other package. So under package P2, package P1 is embedded, and again this is the coding of package P2. So if you have to do the design in terms of the package, you show the abstract package diagram, and then you have to decide the content of each and every package, how that package will be made. Inside that particular package, P1, is there any P2 package, P3 package, P4 package? If P4 package is there, under P4 package, which classes are there, which methods are there, that you have to show inside the diagram. So we will construct the software architecture for the online Bharat Ratna Dr. Babasaheb Ambedkar Library VGTI management system. So we have the library, Dr. Babasaheb Ambedkar Library in VGTI, and this is the manual process. And for this manual process, what you have to do, you have to construct the use case diagram, give your opinion about primary actors and secondary actors involved in the case study, or write the textual use case template or pseudocode for the use case issue book, or construct the state transition diagram for the dynamic class user, or this is the software architecture. You can construct the component diagram and deployment diagram by using the notations. So now you have to work on such type of case studies. And here you should work as a medical doctor, because they have to check the patient and then only they have to subscribe the medicine. If they will forget something, then all things will be in vain. So you should be so careful to do the analysis and design, because in the industry you will get the assignment, you will be a leader or you will be a member of that project, and some work will be allocated to you, and as per the allocation of the work, you may deal with analysis, you may deal with design, or you may deal with testing. So you should have a fully equipped with this analysis and design models and implementation. So here use case diagrams are provided, but primary actors and secondary actors, these are just for the convenience purpose. I cannot say that this is a primary actor and this is a secondary actor, because sometimes secondary actor will act as a primary actor, and some situation primary actor can work as a secondary actor. And therefore, the question is, give your opinion. What are the primary actors and what are the secondary actors in these library systems? So component diagram. So this is the component diagram for the online Bharat Ratna Dr. Babasaheb Ambedkar Library Management System, VJTI. So here, librarian is there, and under librarian, this is library package. Librarian used to deal with part. So under this, book management.java subroutine is there, update details.java file is there, add new book.java file is there, generate bill.java file is there, vendor ID details.java is there. So these are the subroutines that you will implement in the code, so that librarian will deal with this. And this is user package, and in this user package, search book.java, because user will search the book, then user will get the book. So issue book.java, or user can view the book details, or user can return the book. So these three modules are there under the user package. Now, you can also show the interaction among these modules. Now, this is dependency. This is dependency, security. So security deals with non-functional requirements. So security requirements are there, that is registration.java, validation.java, or login.java, or user.java. And on this security, database is there. Now, I said parent-child relationship. So this dependency, librarian is parent, and on the working of librarian, user may get the book. Therefore, arrow is upward. Depends. User depends on this librarian. And now security is a non-functional requirement. And this diagram indicates that librarian depends on security. So flow of information is not proper. What we have studied here, this is child and this is parent. So arrow should be like this. Because this child component or package depends on parent component. So if vertical, parent will be upper side and child will be lower side. If horizontal view, then child will be left side and parent will be right side. this arrow direction should be towards the parent, but from left to right. Here in this diagram, this is not from left to right. So this is wrong. So you have to modify this diagram like this. So now I have placed librarian on this side, user on this side, and security on this side. Because librarian functionality depends on the non-functional requirement security. So here the security is parent package. Therefore, ... arrow is towards security. And this is upward direction. So database is parent. Again, how this database is divided into different types of tables. This notation you can use. Database is there, but how many tables are there? So here you have to show the tables by using this notation. Database is there, table 1, table 2, table 3. You can give the name of the tables. So database tables. So design of the required CPP files. So if this is implemented in Java or in C++, you see, browser will display the user interface files. So login.cpp is there, librarian UI HTML is there, user UI CPP is there. Client mode is connected to the web server via HTTP. So in web server host will, these files will have searchbook.cpp, issuebook.cpp, returnbooks.calculate find. So all these files will be here. You see in the user, search book, issue book, view book, return book. So this is a component diagram by using the notations, package notations you can use, then interaction notations you can use, and inside the package, if other packages are there, you have to show the other packages. If packages not there, if only components are there, you have to show the components with the extension of that file. So here extension, calculate find.cpp. And the web server access data from the library database server via JDBT connection or file handling. So map the component diagram with the code now. So this component, this component, this component, you have decided different types of modules you have decided. Now you write the code for each and every file. You write the code for searchbook.cpp, that is user package. Then write the code for issuebook. So this software architecture having this much files will be mapped with the implementation. So data structure design. So data structure is a collection of elements whose organization is characterized by accessing the function which is to be used to store or retrieve the individual data elements. So if you will think about the data structure, user data structure is there. So user ID, username, password, book ID, book name, author name, publication, number of copies, book issues, and its elements will be there. So this is the data structure design. And therefore, as you have designed this data structure, you have to create this much tables using Oracle or any other database language that you will use for your implementation. So this is data structure design. Tables, you are going to decide the total number of tables and total number of attributes with OCL constant or other constant you can specify. Algorithm design. Now we can map the software architecture with the algorithm used for the implementation of the implementation. So I said that this is the software architecture, and on the basis of this software architecture, you can write algorithm for this, you can write algorithm for this, you can write algorithm for this, you can write algorithm for this. And all these 4 algorithms will be interacting. If they are interacting, you can show the interaction also here. And all these 4 algorithms will be embedded into the package security. And database, table creation. So now we will write the algorithm for each and every file. So I have given some sample algorithms like algorithm calculate due date. So whenever you will decide the algorithm design, you have to write the algorithm purpose of the algorithm. Then you have to declare the variables. What type of variables are used in this algorithm? What is the input and what is the output? So this is algorithm design. So on algorithm design also, there can be a lecture of 1 hour, but now you should be happy with this only. Calculate fine algorithm you can write. Precondition, postcondition terminologies are used in the use case diagram. In the algorithm design, you can say input, output, and algorithmic steps. So now directly you can map this with the code and you can create the table for this. So this is data structure design and this is algorithm design on the basis of the architecture. Now deployment diagram design. So deployment diagram design means what are the hardware requirements and what are the system program requirements. Two things you have to consider: system software requirements and hardware requirements. So in the deployment diagram design, so deployment diagram shows the structure of the runtime system having hardware and system software requirements to execute the software architectures. So under deployment environment, you can deal with client machine, web server, application server, data server with their hardware, and system software such as database, compilers, operating system loaded on each machine, and the application that you have developed. So application that you have developed, that is component diagram, is mapped with the implementation, and that implementation is deployed. That implemented code is deployed on this deployment diagram. So deployment diagram mainly deals with hardware, system program, softwares, compilers, operating systems, browsers, web servers. So if we will think about the web server, what did you understand by web server? So web server is hardware as well as web server is software. Database server is a hardware as well as software. So whenever you will think about the hardware, you have to think the configuration of that database server. And whenever you will think about the software, what is the operating system loaded on that hardware? What is the database that you are going to load on that server? System programs. Compiler is a system program. So processor notation, machine notation is dictated by UML like this, and devices here shading is done. And this is communication line. So these notations are given by the UML, and some other notations related to non-functional requirements are not dictated by the UML. And if we will think about the web engineering, hypertext modeling, presentation, or customization, all these things are not considered by the UML, and therefore there is a need to even extend the UML. You can do the research on UML. So these are the notations or the deployment diagram. So client server deployment. So this is server, this is client 1, this is client 2, and these clients are attached to this server through this switch. This is one example for client server deployment. Now, if we will think about order processing software deployment or library system deployment. So client will be there, workstation, internet is there, then web server will be there. So on this web server, website will be loaded, domain name of the web. So in the deployment, you have to decide what is the hardware configuration of this web server and which web server is loaded here and which component of the software that you have implemented is loaded here. So product bind module is loaded on the web server. Then business server order process module is loaded on the business server. And client order module is also stored on the business server. So product buying, order process, client server, these are the modules of the component diagram, and which component is loaded on which server. That you have to show, that is deployment. Now, data server or database server, this is the notation used for the database server. And here catalog table, order table, client table, TA repository is stored. So here you can specify the table names, but if any coding related to the table is also there, that coding is stored here. So order table, catalog table, client table, these tables are stored onto the database server. Now this is just about the hardware, and the component diagram is implemented, and implemented code is stored on each and every machine. So which code is stored on each and every machine that you are going to show? That is deployment. But again, we can extend it. How we will extend it? Deployment environment, that is hardware and software requirements. So you have to write the hardware configuration, because web server is there. But what is the configuration of that web server? If it is a cloud-based system, whether that web server will work or what? Or what is the operating system? You are using Windows 7 or Windows 10, or you are in need of Linux. Database server, what is the hardware configuration of the database server? Whether you want to use Oracle or MySQL or any other object-oriented database, compiler, programming language, or any web browser or any software tool used. Because if you have to do testing, you have to upload testing tools also. So the executing environment you have to create, where you have to deal with hardware requirement, software requirement in the sense the code that you have developed, and system programs that you have to load on these hardwares. So for this, notations are given. And again, you have to think about non-functional requirements in software architecture. This is the deployment environment for your code. But if you have to think about non-functional requirements, for non-functional requirements, what are the different hardware that you are going to use in your application? That you have to decide so as to improve the performance of the system. So these are various non-functional requirements. You can ask these questions and you can deal with efficiency, integrity, reliability, correctness, expandability, flexibility, interoperability, reusability, availability, quality, and so on. So web application, I am showing here again. So deployment, in deployment, what you can do, this is a, again, library system. Book Club app.war file is deployed on Catalina Servlet 2.4, JSP 2.0 container, which is a part of Apache Tomcat server, and Book Club app.war artifacts are there, and various components are there. So this can be represented like this. This is in terms of UML deployment diagram for web application. So what they have done, they have shown one device, then that device stereotype is written and application server. Now here, JSP server Tomcat 5.5. So this is second server is shown. So in this figure, they have used only one machine for the web server and application server. So they indicated device is application server and JSP server, that is Tomcat server. So this server is acting as a web server and this outsider server is acting as an application server. And then Catalina Servlet 2.4 or JSP container is there. Means they have used this servlet and JSP. So they have written the name here. And then the components of the software that you have implemented. So here Book Club app.war file is there. Then online order component is there. So they ... manifest. This is module. jar file. XML file is also there in the implementation. So web XML is shown. And then this is Oracle database server. This database server is there. And under this again, they have shown other diagram, that is Oracle 10G, database system. So what they have done, this is the database server, that is the hardware. Under hardware, they have shown that other server is there, database server is there. And under database server, these are the tables: user table, order table, inventory table. So if you will provide more and more details, the diagram will become more complex, because here only 2-3 components are there. Therefore, you can combine application server and web server. But if the application is complex, you have to deal with 3-tier architecture, or if it is a cloud-based system, you have to deal with the cloud-based environment. If you are interested in distributed, then you have to deal with distributed environment. And therefore, some other alternative arrangement is done by some other authors, because you see, there are different people, they have different thoughts, they can dictate different notations, they can give their own ideas. You will say something, I will say something, somebody will say something. But if we will collaborate all these people, and if we will collect the best ideas, and again, if you will introduce your new ideas, then it can be a best software architecture. Because the author, lastly, he is a person. He cannot do each and everything correctly, or you cannot represent each and everything correctly in terms of the deployment diagram. And therefore, here you cannot see in which path this software is loaded. We do not know in which path this is loaded. That is a shortfall. This is specification level again. Package is there. So folder name they have given. Under this package is stored into this folder name. And under this folder, file is there, web.xml is there. And under this folder, again, this package is there. And inside this package, these are the modules. And outside of this, again, some components are there. Shopping cart, order, these components are there. So these components will be stored on the application server, if it is a web server. In this web server, book club app.war file is there. So if it is a web server, this is an application server. And on this application server, these two components are loaded. See, shopping cart and order. This connector is used here. This is the port, because order can be placed through this port. Shopping cart can deal with this port of the order. So these notations are used. So instead of this, many diagrams, you can prepare this. What you can do, you can construct the 3-level architecture, or it may be a cloud component diagram, hardware requirements, software requirements, system program requirements. And below the diagram, you can do this table. In this table, what you can do? Machines used, software used, hardware configuration, operating system, then compiler used, any other software used, and software modules and path. Software modules and path. Whatever may be the software that you have implemented, it may have different packages. Different packages will be allocated to different machines. So on a particular machine, in which drive, in which path that component is stored, then only you can create the executable environment. Because this is just the design. Component diagram and deployment diagram is a design of software architecture. And on the basis of this design, you have to deal with the real life executable environment. So here, machine client, software, you can write here what is the software. You can write the configuration of this client machine. Operating system used on this client is Windows 10. Suppose compiler is used Java or any other software, Google Chrome 67 is used on this client. and GUI is there. What is the path? In which path that GUI is stored? Web server. So web server is there. So Apache web server is loaded. Or you can load IIS service web server, or you can load Tomcat server. Depends which server you would like to load. It depends on the programming language. Now, for this web server, Sunfire X4150 server is used. So when you are writing the name of this server means what? This name of the server indicate the detailed hardware architecture. So you have to select the particular configuration only so that you will meet the performance of the system. Otherwise, your system will become slow. It may not give the performance. Therefore, for the web server, this server is used. Now, Apache web server is used. Operating system used can be Red Hat Enterprise Linux 5, or you can use Windows, you can use Mac, or you can use Apple OS X. So only you have to select this operating system only. Then only this web server will work. And Java is there, PHP, Perl, and Python is there. Any other software, you can write the software. Path, D drive, and under D drive, that particular component is stored. Complete path you have to write. Now, here in web server, I have written, I am going to use IIS server. If I will use IIS server, then we have to use Microsoft Windows only. And compiler should be ASP.NET. Then only you can work. If you will not use ASP.NET here, if you will use Java, so it will work on Microsoft Windows, but sometimes it may not work with IIS service web server. So for the web server, particular hardware should be selected, particular web server should be selected. On that particular web server, only particular programming language can be used for the implementation of your software. That you have to decide. It is not a random process. What is the requirement? What is the programming language? That programming language will work on which operating system, on which web server, with which database. So you have to think about the compatibility while design the deployment diagram. So you have designed the deployment diagram. These are the deployment diagrams. But below that, you can give the details, because it is difficult to provide all these details into the diagram. So this is, you can say, allocation style. That module view type, component connector view type, and third is allocation style. So you can say this is the allocation style. Deployment application server. So on application server, Apache Tomcat is there. So Apache Tomcat can work with Mozilla Firefox or Windows or Linux, and only compiler languages will be this. So if HTML, Java, ASP, JavaScript, Oracle application server is there, then you have to use only and only Tomcat server. If you will use IIS server here, then this will not work. Here you write the path, that client order package is stored on this path. Here system program. Or again, you can deal with the details of hardware, processor, RAM, STD, and so on. Now, in this diagram, network architecture diagrams are not shown by the UML. So UML standard has no separate kind of diagrams to describe the network architecture and provides no specific elements related to the networking. So UML is shortfall of network architecture diagram, because network architecture diagram is also the part of the component diagram, and UML is not providing any notations for it. So network architecture diagram will usually show the nodes and communication path. Here I have written the note. Note that this diagram uses networking icons that are not part of the UML standard. Specifically, I have made this statement here. So suppose this is the internet, these are your servers, and you want to put router, firewall, ideas. So for this, they have not used the notations. So these are the informal notations of these devices, which may come from the previous three diagrams. Allocation style. So on the basis of allocation style, for the security requirements and for routing requirements, I can put router, firewall, ideas. Or internet is there, router is there, intrusion prevention system is there, firewall is there, then DMH zone is there, LAN environment is there, WAN environment is there. So for that, they have not provided the notations. So you can provide your notations, or you can use the same notations provided by the UML, like device notation, and there you write the stereotype. This is DMZ stereotype, or this is firewall stereotype, or this is IPS stereotype. Again, company employees are there, IPS is there. So there are no notations. So I mean to say that either you can use the device notations provided by the UML, or informal notations, or you can use the stereotype. This is your component diagram machines, but this is the external environment for the security. So thanks to you all. There are many, many things. But I will stop here only. Stopping presentation.
Yes, sir. So now I'll do vote of thanks, sir.
So I'm doubtful whether they could understand or not, because it was difficult to complete the topic within 1 hour, but I think it is more than 1 hour.
No, sir. They understood each and everything, and they posted the comment on chat box also, sir.
Oh,
Okay.
they may put wrong comments about me. I
No,
don't
sir.
mind.
No, sir. No, sir. They will give feedback to sir. Okay, sir.
Okay, okay, okay.
Okay, sir. Sir, good afternoon all. On behalf of SLRTC IT department, I would like to thank Dr. B.B. Meshram, sir, for taking out time from his busy schedule and sharing his knowledge and expertise with us. Session was wonderful and informative. It was a detailed description of component diagram and deployment diagram. Once again, I must say thank you, sir. I would like to thank you, Mr. Sunil, sir, HOD of IT department, Dr. Anju Arya, madam, director of SLRTC, and Dr. S. Ram Reddy, sir, principal of SLRTC, for giving opportunity to conduct such webinar. Thank you all the students and faculty for attending this webinar.
So,
Sir, two students will also give the feedback. Yes, yes, Vinit and Manish. Yes,
Yes, ma'am.
Manish. Ha.
Yes, ma'am.
Ha.
Hope I'm audible. Thank you, sir. It was a really a grateful session. It is not that we didn't understood. We understood everything from component diagram to different flaws you said in the UML and the practical implementation of Baba Ambedkar library at your college. So it was, I know the time was very concise, but the information you provided was very fruitful one, and we were patiently listening everything. So it's not that we didn't understood. And also the flaws which you mentioned in networking at the last, we understood everything. It was a really a great session. Thank you so much, sir. And thank you so much to our college and principal ma'am, Dr. S. Ram Reddy, sir, and Anju ma'am, and also our teacher, Madhuri ma'am and Dipali ma'am, for having such a great session. We are very fruitful and like advantages for these teachers to have such a session. And thank you so much, sir.
so I
Yes.
thanks to Dr. Reddy, sir. I think Dr. Reddy is not there,
Yes, sir.
but he is always with me, and I was on first committee to start your college.
Yes, sir. It was a great pleasure, sir.
Thank you to you all.
Yes, sir. Sir, now we have the quiz session, sir. Sir, if you want to stay, you can stay, sir. Five quiz on
No.
Kahoot, sir. Okay, sir. No.
So I have some other work.
Okay, okay, fine, sir.
I have some other lecture and meeting also.
Yes, sir. Yes, sir.
So
Thank you very much, sir.
you can conduct the quiz.
Yes, sir. Yes, sir.
So
Definitely,
if
sir.
you have said, I would have floated the objective type questions. But let
No
it be
problem.
now. Let it be. Okay.
Okay. Thank you very much,
So
sir. Thanks a
thank
lot.
you to you all. Thank you all, professors, head of department, principals, and management. I know the management. I know how they have connected their each and every colleges to video surveillance. Thank you
sir.
to you all.
Thank you, sir. Thank you.
Thank you.
Thank you, sir. Thanks a lot, sir.
So I will leave the meeting. Okay.
Yes, sir. Yes, sir.
Thank you.
Thank you.
Okay, students, I posted the feedback form link in the chat box. So fill that feedback form, okay, for the today's session.
And madam, we will have the quiz also. Okay.
Okay. Yeah.
So student, join the quiz on Kahoot.8. Before that, I need to share my screen now. So all of you, please log in into Kahoot.8. This is a pin for our quiz. So all have to join. Join fast, students. I will start within 1 minute. Should I start, students? Your quiz is based on your software architecture component diagram and deployment diagram. Basically based on your webinar. Just now we have attended. Should I start, student? Okay, let me start. Yes, Deepali ma'am. Yes, Deepali ma'am. Start karu ya?
हाँ करा मैम.
Okay, ma'am. Thank you. Yes, we'll start. The first question is, what does software architecture means? It is the structure or a structure of system. It comprises of software component, relationship among components, all of the mentioned. It's very simple. Yes, 34 students gave the correct answer. And on scoreboard, Abhirami, Rakesh, Vivek, Adi, Pallavi. Congrats, students. A component diagram is used to describe filling the blank between various software component of the structural diagram. Option is inheritance, dependencies, classes, objects. Okay, 21 students gave the correct answer. Very good students. Manish, Meherin, Faiz, Bhargav, Ankit. Congrats, students. Which of the following is does not include in the component diagram? Dependency, generalization, association, aggregation. Seventeen students gave the correct answer. Now who is in scoreboard? Faiz, Pratik, Bhargav, Moksh, Shalu. Wonderful students. Okay, now the fourth question. Identify the computational elements of your system deployment view and model as a node is modeling processor and devices, modeling the distribution of components, modeling source code, modeling primitive types. Only 6 students gave the correct answer. Question is somewhat difficult. And scoreboard, and that Bhargav, Faiz, Pratik, Moksh, Shalu. Very good. Now the last question, filling the blanks, show the configuration of runtime processing nodes and the component that live on them. Use case diagram, component diagram, class diagram, deployment diagram. Very simple. Runtime processing nodes. Thirteen students gave the correct answer. Well done, students. Now who is in podium? Shalu. Congrats, Shalu. And second position, Faiz. Very good, Faiz. And who is the winner? Bhargav Joshi. Congratulations to winner. And runner-up is Moksha and Azim. Very good. We'll get a feedback of this. Okay. Okay, thank you, all of you students. And thank you, Dipali ma'am. Should conclude the session. Yes, madam.
Thank you. Thank you, ma'am.
Okay, student, you can leave. Okay. Yes. Once again, thank you, all of you. And have a great day ahead. Chalo, bye, students.
Ma'am,
Ha.
Madhuri